हेलो गाइस, वेलकम यू ऑल टू एआई की पाठशाला। एआई की पाठशाला आपकी अपनी पाठशाला है एंड वॉट एवर सेशन आई एम कंडक्टिंग हियर इट्स एब्सोल्युटली फ्री ऑफ कॉस्ट। एंड दोज ऑफ यू हु वांट टू ज्वाइन माय फ्री लाइव सेशन यू कैन गो टू द डिस्क्रिप्शन सेक्शन ऑफ द वीडियो एंड ज्वाइन माय टेलीग्राम group from the link attached there. By joining the telegram group you can have an access to all my upcoming live sessions. So I usually conduct live session at 9:15 p.m. IST, and sometimes during the holidays even I conduct the session during the daytime. So that's all. Today is the fourth session in NumPy, and we will discuss a lot of things. So let me share you my screen first, and before that, before starting the actual discussion, I will share you one population.txt file inside the chat window of chat window. You have to download that folder and keep it in the same folder in which you are opening your file in your VS Code or in Jupyter Notebook or whatever things you have to, but you have to keep that file in the same folder. Otherwise, if you are not keeping it in the same folder, then you have to specify the path location. That is, you have to specify the path. So if you do not want to specify the path, simply you need to open it by simply putting the name of the file. Then you have to keep it in the same folder. So this is all. So let me share you my screen first. So created this folder, GitHub repository, and created the name file session4.ipynb. So the first thing that I am going to do, so I have already given you the population.txt file in your chat window, and I will also upload that in the GitHub. So you can download it. Whosoever is watching the recorded session, you can go to the GitHub and download that file, because that we are going to discuss right now. So first you have to download it from the GitHub. Fine. So, and the link of the GitHub is attached in the description section of the video. So you can follow that link. You will get that file. So now, first thing that I'm going to do is I have to import NumPy. So let's import NumPy. Let's import NumPy as np. This is the first thing. After that, I have to load that data file populations.txt inside this here. So for that, you have to write data is equal to np dot load txt, and then name of the file populations.txt. And if you will run this, you will get this data get loaded. Now I want to see what is inside my data. So you have to simply do this, and it will give you the things that is inside your data. So let me show you this thing. First, let me show you one thing. Let's see. This is the population.txt file. So let's first here. Are you able to see this population.txt?
Yes, sir.
If you will see this, you see there are inside this folder population.txt, there are 4 columns. My first column is the year. Second column is the hair. Hair is also called rabbit. RABBIT. Hair and rabbit. Rabbit is the another name of hair. This is a lynx. What is this lynx? This is basically a wild cat. Wild cat. And this is a carrot. Fourth row, fourth column. So there are 4 columns in this file, txt file. Now what is happening that the population of year-wise population of all these 3 hair, lynx, and carrot is given. In a particular year, what is the population of this hair, what is the population of this lynx, and what is the population of carrot. Now this hair rabbit eat carrot, this hare or rabbit eat carrot, and this lynx eat carrot, and this lynx, which is a wild cat, eat rabbit. So this is all about this. And can you see here in the population section of lynx and here it is written in this form 21. Let's take this population 21.4 E3. This is a 21.4 E3. This is a scientific notation to write the number. So what is this? E3 is basically 10 raised to the power 3. So you can understand this by this way. It is basically nothing, 21.4 into 10 raised to the power 3. This E3 is 10 raised to the power 3, which you can also write it like 21400. All these three things is same. So you can have, you must having a, this is my ear, this is my ear, this is my rabbit or hare, rabbit, this is my lynx, and this is my carrot. So if I will write here, it will be like ear, hare, lynx, and carrot. Fine. So these are the 4 columns inside my file. Now let's do one thing. I want to, let me tell you one important thing. Let me discuss you this thing first. Then I will would like to discuss something new. So there is called one thing called transpose of a matrix. What is transpose of a matrix? Let's understand it. Let's see if this is my one matrix called 1, 2, 3, 4, 5, 6. Let's say this is my one matrix A. For calculating the transpose of a matrix, you have to do A transpose. And mathematically in the program, this is a symbolic representation of the transpose of a matrix. And in program, you have to write A dot T. It simply means you are transposing this matrix. Transposing simply means you are converting the row into the column and column into the row. So here my column, here is, what is my row? 1, 2, 3 is in my row. So let me convert this into column 1, 2, 3. This is my first row. This is my second row. First row. First row. This is my second row R2. I have converted my first row into first column. Now take this second row and convert this into column 4, 5, 6. This is my A transpose or transpose of this matrix. If you will see the size of this matrix, what is the size of this matrix? 2 cross 3. 2 cross 3. What it means? There are 2 rows and 3 columns. And what is the size of this matrix? This is
3 cross
3 cross 2. Because while transposing this matrix, the row becomes column and column becomes row. This is how the transpose operation work in matrix. Now, let's do one thing. So this is ear, here, and hairs, and this is my links, LYNXES, lynxes, and this is my carrots, CARROTS, carrots. Fine. Let me write data dot transpose. I am transposing this data. What it means? I am writing I want to do it columns, column, columns to variables. variables. Fine. Let me write it. Now let me print year. I want to print year. Print year. If I will print year, I will get all those years. This is my 4 variable. I have converted this. I have transposed this and saved each one of the columns to this variable. Let's say I have saved this in a year. So now if I want to access this year variables, what is present in my year, I will get the list of all the years that is present here. Now, if I will get this, let's say if I, that means in any particular year, any particular year, let's say in this year 1905, this is the population of hares, this is the population of lynx, and this is the population of carrot. I want to calculate the mean population over time. So for that, what I want to do, let's first see for calculating the mean population. Let's say if I want to calculate the mean population, so mean population in any particular year, if I want to calculate, or mean population in all these years, let's say if I want to calculate the mean population in each one of the year from 1900 to 1920. For calculating the mean population, I do not require this column, this year wala column. I only require these columns, these 3 columns, because my actual population is in these 3 columns, in rabbit or hares, lynx, and carrot column. So I need these 3 data. These 3 population data I require only. So I do not require this year column. So I have to remove this column from my population.txt data. So how I will remove this? Let's see. My purpose is to calculate the mean population over time. And Varun, whenever you will face any difficulty in understanding, please ask question. Don't sigh in asking question. Now see, I am writing population, and after that, I am writing this data. This is a population is my variable. Now, to calculate the mean population in each one of this row from 1900, in each one of the year from 1900 to 1920, what I need each one of the rows. I require all the rows. So I will simply write this thing. We already have understood this in the case of slicing. What it means, it will start from the first row and it will go till end row. So it will give me all the rows. This means this will give me all the rows. Now inside the population column, I do not require this year wala column. I only require these 3 columns because I have to calculate the mean of these 3 column only. So I am writing 1 colon, and that's all. So what it means, it will fetch the population from first column. So from first column means it will take into consideration, this column, and this column, because this is my 0 column, this is my first column, this is my second column, this is my third column. When I am writing 1 semicolon means it is starting from the first column and it will go till end column, and end column is my 3. This is my end column. So it will only take into consideration these 3 columns. it will not take this column. It will just remove that column. So let me now go, if this thing is clear to you. So let's understand here. Now, if you will simply do this and fetch the population, let's fetch the population and see what happens. Can you see inside the row, I am getting all the rows, but inside in the column, I am getting all the rows because I have asked to give me all the rows, but inside column, I am getting only 3 columns. It is skipping the 0th column. Now, since I have got this data, now I want to calculate the mean and I want to calculate the standard deviation, let's say. So let's first calculate the standard deviation. So how you will calculate the standard deviation? Let's first calculate standard deviations. Standard deviation. So for calculating the standard deviation, this is very simple. This is very simple. What you have to write? You have to write population dot std, and then you have to give axis is equal to 0. What it means to give the axis is equal to 0? Axis is equal to 0 means it will calculate. Let me first, do you remember what does the axis is equal to 0 mean? Varun, can you tell me?
Yes, sir. It calculated the standard deviation along the rows.
Axis is equal to 0 means rows?
Sorry, sir. Column.
Fine. It will calculate the standard population.std axis is equal to 0 means it will calculate the standard deviation along the column. So it has calculated the standard deviation because there is a 3 column here. In this column, in this column, and in this column. In all the 3 columns, column wise, it has calculated the standard deviation and it has given me. If you will, instead of this, if you will do, let's say if you want to see which species has the highest population each year. This is my question. Let's write which species has the highest population each year. Fine. So we have already discussed this thing called argmax. So let's write np.argmax, and you have to supply here first your data population that is there, and then you have to specify the axis. So let's understand what this argmax will give. Which species has the population each year? What I have told you, which species has the highest population each year? That means in every year, starting from this first year to the, starting from first year means starting from this 1900 till 1920, every year you have to decide, you have to give in each one of these 3 the population of which thing is highest. Is the population, if you see here in 1900, can you see the population of 48,48300? This population is the highest. If you see in this year, still this population is highest. If you see here, this in 1902, this population is highest. Population of hares is highest. Similarly, if you can see this, the population of lynx is highest in 1904. So In this way, you have to calculate in each year which of the population is highest. For calculating the highest, I am using this np.argmax. I'm supplying it a population and I have to specify the axis. This time, what I have to, I will give here axis is equal to 1. Because why I am giving axis is equal to 1?
Yeah, because the population of species is in the row.
Right. Because I want to perform the operation row wise. Inside my row, in each one of the row, I am performing. Last time here, I was performing the operation along the column. So if you just give this, it will give you. Can you see? It is giving. Now, you from the earlier knowledge, we know that this argmax will give you the index. It will not give you. So this is my here. If you will see, this is my 0th index in this case. This is my first index and this is my second index. So what it is actually giving you, it is giving you an index value. In each one of the year, it is giving you the index value of the highest population. Fine. And with the help of this, you can calculate the highest population in each year. Fine. So this is one way to understand this simple data set and to do some basic work with this data set. Now, let me move to something else. And this is a very important concept. This is my matrix. This is my 2 into 4 matrix. No, 3 into 4 matrix. This is my matrix. This is my first matrix, which is 3 into 4. There are 3 rows. Sorry, 4 rows, 4 into 3 matrix. There are 4 rows. This is my rows. R1, R2, R3, R4. And this is my column. 3 column. C1, C2, C3. And this is also a matrix which is having 3 column, C1, C2 and C3, and 4 rows is there, 1, 2, 3 and 4. So what I'm doing, I'm here, if you will see, I'm doing a matrix addition. And the shape of this matrix and the shape of this matrix is same. Here also we have 4 into 3 matrix. Here also we have 4 into 3 matrix. And when this is the condition, and what I'm doing an element wise addition. This thing and this thing is same. I have written for just for the purpose of making you understand, because I have written something below here. So you will understand these thing and this thing are same. So don't get confused. Everything is same. Whatever I have written here, same thing I have written here, and whatever I have written here, same thing I have written here also. So when I am doing this element wise addition, so this 0 get added to this 0, and I am getting, and this is my output. This is my output. This matrix is my output. After adding these two matrices, I am getting the output this. So if you will see, 0 get added to 0 and I am getting 0. 0, 1, 1, 0, 2, 2, 10, 0, 0, 10, 10 plus 1, 11. I am getting 11. 10 plus 2, this 10 and this 2 get added. I am getting 12. This 20 plus 2 get added. I am getting 22. This 20, 1 plus 1 get added. I am getting 21. This 20 plus 0 added. Similarly, 30 plus 0, 30. 30 plus 1, 31. 30 plus 2, 32. So this is how you are getting the addition of these two matrices. Now let's come here. If you will see this matrix, this is basically my 4 into 3 matrix. Similarly, this matrix, whatever matrix I have written above, it is same as this matrix. And if you will see, this is basically my 2-dimensional matrix, because I have my rows and I have my column. But if you see this second matrix, this second array, this is my matrix 4 into 3 matrix, and this is my simple array, 1-dimensional array, whose value is 0, 1, 2. 0, 1, 2. There are 3 values inside this array. So, but this is my 2-dimensional, this is my matrix having 2 dimensions. I want to add this matrix with this array, but this will not get added because the dimension of these two are not matching. There is a shape mismatch. So for doing this, what we have 4 rows, na? 1, 2, 3, 4.
Yes, sir.
Here we have only 1 row. So if I add 3 more rows here, then it will become 4 rows.
Yes, sir.
So what I'm trying to, what I will do here, I will simply replicate this array 3 times, or you can say 4 times in a row. This simply means replicating this array 4 times in a row. If you replicate this array 4 times in a row, you will get exactly like this array. You will get this thing. Can you see? If you replicate it 4 times, you will get this thing. Can you see this? And you will keep this as it is. This is as it is. This is as it is. If you keep this as it is and replicate this 4 times, you will get this array, new matrix. You will get this new matrix. Now the shape of both these matrices are same. Now it can perform an addition operation and you will get the same result here. This process of replicating this array, row wise, this is called broadcasting. We are broadcasting this array to match this shape with this array, so that I am able to perform this addition operation. This process is called broadcasting. And this is a broadcasting, row-wise broadcasting. This is a row-wise broadcasting because we are adding the same row. We are adding here 3 more rows inside this. So this is called row-wise broadcasting. Now, if you can see this thing, this is exactly what this is. This is exactly this column. If you will see, this is exactly this column, one column. If let's say you have this case in which one column is there, this is 1-dimensional matrix in which we have one column 0, 10, 20, 30, and this is also my 1-dimensional array in which only I have a row which is 0, 1, 2. Now let's say if I have to add these two array. So what is the way to add this two array? To add this array, you have to see in this array, in the first array, there is only, this is a column array and this is a row array. So to match this, you have to broadcast this column array. That means you have to make the you have to replicate this column 3 times. Can you see this? I am replicating this and I am exactly getting this thing only after replicating. Can you see? I am getting this matrix only. This matrix only I am getting after replicating this 3 times. And you have to replicate this row wise 3 times, 4 times. If you will replicate this row wise 4 times, you will get exactly this matrix. Now you are matching. This is also 4 into 3 matrix. This is also 4 into 3 matrix. And if you will sum this, you will get exactly the same result. Here also, this process of replicating this matrix row wise or column wise is basically called broadcasting conceptually. So do you got this concept? The concept of broadcasting?
Yes, sir.
Now I will keep on coming to this thing again and again. So there is one function called tile. So to broadcast this kind of thing, you have to use something called tiling. So how you will do? Let me write one array. A is equal to np.tile. This tile means, and let's inside this I am creating one array np.a range, and let's define the range 0, comma, let's say 40, comma, let's say 10. And after that, let's write here 3, comma 1, comma 1. And thereafter, I want to print this A. Now let's first understand what I have written here. Then we will move ahead. So let me write this. See, this thing, let's first focus here. What this thing will do? This thing will create an array. And what is my array? This thing will create, this is 0,
10, 20, 30.
10, 20, 30. This is my array. Now, this tile function is used for broadcasting. Fine. You have understood this. Can you see the tiles? Tile is like that. You will keep one tile above another, one tile above another, just like the replication in case of broadcasting you do. The same thing for doing the broadcasting, you require this tile function. np.tile, you require this. Now what you are asking here, tile, you have written this array. This array is, this is my array. This is my 0th first, second and third index. I am writing here. Then after that I am writing here 3, comma 1. What it means? It simply means you are telling here, telling this thing, this array, you are telling with the help of this tile function, you are telling that broadcast 3 times row wise, and 1 time column wise. 1 time column wise. So what it will do? It will broadcast itself 3 times row wise and 1 times column wise. So what it means? If it get broadcast 3 times row wise, what is the final thing that I will get? I will get, after performing this operation, what shall I get? I get 0, 10, 20, 30, 0, 10, 20, 30, 0, 10, 20, 30. Can you see this? Can you understand this? If I am asking it to broadcast 3 times row wise and column wise, I am asking it to broadcast only 1 time. So this is the one time that it has already broadcasted, so it will remain the same. Now, if you will go here, this program and see what I am getting. Let's run this program. So let's run this. Can you see you are getting 0, 10, 20, 30 3 times? It has broadcasted.
सर
Do you understand this?
ये सर समझ में आ गया, बट सर ये जो कॉलम का बने वाला समझ में नहीं आया.
क्या चीज
The
समझ
three
में नहीं
times
आया?
the three times rows broadcasting I have understood, but the column one I have not understood.
This is that column wise you have to broadcast only once. So this is broadcasting only once. You will understand this. Let me make you understand this. Let me just wait 1 minute. Let me do one thing. Just I'm copying this entire code and just paste it here and just change the value of 1 to, let's say, 2. And simply run this. Okay. And let's access A. Now, see. Column wise, it has broadcasted 2 times.
Okay, sir,
Earlier,
understood.
earlier it was
Understood.
broadcasting only 1 time. This time it was broadcasting 2 times. Do you get it?
Yes, sir, understood.
Understood? Now. So now one very important thing that like to discuss here. So let's skip this thing. Let's skip this thing only because I want to use this thing in my ever. So let's do this thing. If I run this, you will get this. Now, if you will do, let's say you want to make a transpose of this A. So what will happen if you will make the transpose of this matrix? If you will make the transpose of this, so what you can do? If you will write A is equal to A transpose A, and simply if you print A, what you will get? This is my A. Let's understand this. This is my A. This is my A. If you will transpose this, the row will get converted into column. So what is my first row? 0, 10, 20, 30. Convert it into column. 0, 10, 20, 30. Second row, 0, 10, 20, 30. Third row, 0, 10, 20. This is my A transpose. Means I am converting my row into my column. And this is my A transpose. So if you will run this code, you will get your same thing. Can you see 0, 10, 20, 30, 0, 10, 20, 30, 0, 10, 20, 30? Are you getting the same thing or not?
Yes, sir.
Fine. Now, if you will see one thing, let me explain you one thing. Yes. This time what I'm doing, let's take this thing. Your this thing. Fine. And I'm going to transpose this. Let's run this thing and then do A is equal to, first run this, you will get the same output. Thereafter, let's clear this. Let's do A is equal to A transpose and let's print A. Let's print A. Can you see how it is getting transposed now when you are broadcasting 2 times column wise? So it is taking 0, 10, 20, 30. Then again 0, 10, 20, 30. 0, 10, 20, 30. 0, 10, 20, 30. 0, 10, 20, 30. 0, 10, 20, 30. 0, 10, 20, 30. 0, 10, 20, 30. Got this?
Yes, sir.
Fine. So this was one thing. Now let me go to the next concept before it, because I want to use this thing. So I printed this. Now see one thing. I want to do something. Let's take one another array is equal to b is equal to np dot array, and let's write 0, 1, 2. 0, 1, 2. Let's write this thing. And if you print b, you will get this thing 0, 1, 2. Now if you will do a plus b, a plus b, what will happen if you will simply do a plus b? What is my a? A is my this thing 0, 10, 20, 30. 0, 10, 20, 30. 0, 10, 20, 30. B is my 0, 1, 2. If you will write this, able to broadcast it together. So for broadcasting, what we have to do? We have to match the same. Fine. Let's understand this with the help of one example, or let's write one array np dot a range, and same write 0, 40, 10. If you will see the shape of this, what you will get? 4, what it means? This means this is a one-dimensional array. 4, simply means this array is one-dimensional array. This is 1D array, and this is having four elements inside it: 0, 10, 20, 30, and this is my one-dimensional array. This it means simply. Now, to convert this into a 2D array, there is one method to convert this 1D array. This is my 1D array, and I want to convert into a 2D array. For converting into a 2D array, we have to add one new axis to it. And for adding the new axis, this is a way to add a new axis to it. Let's write, I have written this a is equal to a, and I want to take all the rows, and since it doesn't have any column, in the column let me add one axis called np dot new axis. This new axis, what this will do, it will add a new axis and convert this into, let's convert this into 2D array. 2D array. Right? And then if you will check the shape of this array, then if you will check the shape of this A, let's see what you will get. You will get 4, 1. Earlier you are getting 4, that means this is a one-dimensional array, and now you are getting 4, 1, that means this is a two-dimensional. Now it has become a two-dimensional array, and this np dot new axis, one axis get added, and this axis is 1. So to convert the dimension into a to add a dimension, this is one way to add a new dimension. called np.newAccess. Hope this thing is clear to you.
Yes, sir.
Now, if you will check this, let's check what is a now. Now it is giving you this. It means it is having a 4 rows, this 4 rows and 1 column. Earlier, it doesn't have the concept of rows and columns. It simply, it is in a line. 4 values is there. But now it has got 4 rows and 1 column. So this is a row 0, 10, 20, 30. These are the 4 rows and there is only 1 column. Now what is my B? Let's see what is my B. Let's write. B is my this. This thing is my B. Let's add A plus B. Shall I get this thing?
Sir, I've got the same result.
What?
Sir, I've got the same result, but sir, how come I don't know?
How?
Sir, how has it? Sir, how has the result came like this? That I'm not understanding.
Yeah, I am not actually understanding. I am not getting your voice very clearly. So please speak a little bit louder.
Sir, result is same, but
Fine.
how this result has come that I'm not understanding.
Okay, okay, okay. Let me explain you. Fine. So to simply what I am doing here, just now I have explained you the same concept I am doing. I am converting this. I am broadcasting this column wise 3 times and I am broadcasting this row wise 4 times. And I am getting this thing. I am getting this thing. And then when I am adding, I am getting the same result what I was getting earlier. Now, the thing is that why it was not working earlier by a 0, 10, 20, 30, 0, 10, 20, 30. And this is my 0, 1, 2. This can't get broadcasted because, see here, this is 0, 10, 20, 30. 0, this is 0, 1, 2. 0, 1, 2. Even if, how can this get broadcasted? Even if it gets broadcasted, let's say row wise, it will not match it
Sir, समझ में.
because of the shape mismatch.
Yes, sir. Understood.
Understood?
Yes, sir.
But,
yes, sir.
But here in this case, there is no such issue because it can able to, this thing is able to broadcast row wise. This thing is able to broadcast row wise, column wise. It can broadcast and this can broadcast row wise. And whatever be the number of, after broadcasting, the number of column in this and number of column in this will remain same. So it will able to broadcast and then it is able to get added. So have you understood this?
Yes, sir. Yes, sir.
Is the concept become clear? Because it is very important to
Yes,
understand
sir.
the concept. Otherwise,
हाँ जी,
fine.
sir.
तो अच्छा ऐसे ही आप क्वेश्चन पूछते रहिए. सो अगर ये आ गया है तो फिर ठीक है, हम लोग अब नेक्स्ट टॉपिक, नेक्स्ट चीज पे मूव करते हैं. लेट्स मूव टू द नेक्स्ट थिंग. Let me erase all those things. So let me erase these things. Fine. Now, तो हम लोगों ने ब्रॉडकास्टिंग का कंसेप्ट कर लिया and this was a very important concept. Now there is one concept called flattening, which is also called array shape manipulation. This is also called Flattening. Flattening is called array shape manipulation. So what flattening is? Flattening is very simple. If I write one array, let's say A is equal to np.array, and inside this, if I will write 1, 2, 3, 1, 2, 3, and 4, 5, 6. That's right. This is my array. So this array is, this is my, what is the dimension of this array? Varun, what is the dimension of this array?
The 2D.
2D array. Correct. This is a 2D array. So what this 2D array will do, if I will simply flatten this a dot revel is the this is the function to flatten the any array. So if simply you will write it, it will convert this two-dimensional array into a 1D array. Whatever be the array is there, it will simply convert this into a 1D array. So if you will run this, you will get array 1, 2, 3, 4, 5, 6. So this was a basically this was a matrix. This was basically a matrix, 2D matrix. 1, 2, 3, 4, 5, 6, and it has simply converted into a straight line. This is a straight line, 1, 2, 3, 4, 5, 6, 6, whatever. So this is the flattening operation. This is simple meaning of the flattening operation. We will understand few more things inside this. So if you, this is the flattened value. Now if you will check A, let's check A. You will get this 1, 2, 3, 4, 5, 6. Now if you will do A transpose, if you will do A transpose, what it will give you? It will give you 1, 3, 1, 2, 3, 4, 5, 6. This is basically a transpose. And let's say if you will ravel now, this is my A transpose. And if you want to ravel now, A dot basically T dot ravel, if you will perform this, now you will get the flattened value. Here the flattened value of this transpose matrix you will get. What is the flattened value? 1, 4, 2, 5, 3, 6. 1, 4, 2, 5, 3, 6. You got it?
Yes, sir.
Now, this is called reshaping or the inverse operation to flattening. This was the flattening, and when you will study this machine learning, deep learning, advanced things inside this, there you will use this flattening concept, this broadcasting concept very much. So inverse, this is called reshaping or also called reshaping, also called inverse of flattening. The inverse operation to flattening. Inverse operation to flattening. So how you will do it? Let's first print a dot shape and see what I am getting. 2, 3. It is fine. A is my 2 rows and 3 column. Now let's also print a let's see, print A. This is my print A. This is my A. Now, if you will write B is equal to A dot revel, and if you will print B, what you will get? Same thing you will get. Can you understand what I was doing? See, this
Yes,
is
sir.
my A, Varun. Understand this here. This is my A. Now I am performing the revel operation on A, and I'm saving this output. Whatever output I am getting after this, I am saving this output in some other variable called B. Here I was doing simply A dot revel. I was doing this A dot revel, and I was not saving this inside any other variable. I was simply performing the operation on this only. But here, what I am doing, I am performing this operation A dot revel, and I am saving the output of this this output of this A dot revel operation on in some other variable B. Now I am printing this, the output will remain the same. But what point that I want to tell you is that now see, now if you will do B is equal, now if I will write B is equal to B dot reshape, and let's reshape this. I can reshape this because this is having a 6. But I can reshape this. Let's reshape this 2 comma 3. If you will reshape this, and if I want to print this, let's print this. Let's see. I am getting this thing 1, 2, 3, 4, 5, 6. So if you will reshape this B, you will again get the same thing 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Do you got this point?
Yes, sir.
So this is after revealing, I am reshaping it, I am getting the same thing. Now,
Sir, I
if
want
you
to ask one thing.
yes,
Sir, when we have done the normal A dot revel, when we have not stored in a variable, sir, commas were coming in between the values. But when we are storing it in B, the commas are removed.
let me see. Yes. Oh, great. So if you will, let's say let's write print A comma revel here. Let's do. Can you see? Comma has been
Okay, sir.
removed right now.
Okay, sir.
Fine. So there is no such thing. Now, let me rerun this because it has saved that thing. Transpose, fine. Reset. Now, if I will do, this is my B. Let's see if I want to assign, let's say instead of this A, here I want to assign some other value. Let's say I want to assign 500. So what you have to do? You have to simply specify the index position. So what is my index position? 0, 0. Is this my index position? This
Yes,
is
sir.
the 0th row and 0th column. Let's say if I will write this 500, and if I run this and see my B00 and see A, not B.
Sir, you should write B here. You have printed A.
Wait, let me do this. Yeah. Actually, the thing is that what I have made changes here, na print. That's why it is. If I will write a transpose shaping, reshaping a then a dot rebel, a dot reshape, b dot a. Fine. Actually, I have made changes at that time, na. So it will. It was not working. The point that I want to explain you is, let's see why I have done this. There is a reason. Hey, this is my B. Can you see? This is my B. And I have assigned 500 here in place of 1. But when I am accessing my A, there also value get changed. Why this is happening? Let's first understand this. What was my A? My A is this. My A is this thing. My A is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And when I am assigning, and my value at A gets changed, when I am assigning a new value to B, the value at A get also changed. This is happening because this was my A, and whatever value I got after performing the revel operation on A, I am assigning it to the B. I am assigning it inside one variable. So what this NumPy is doing to save the memory to make more efficient, the memory location of B is same as this. The memory location of A and B both are referring to the same memory location. So since both are referring to the same memory location, so if I am changing a value at B, it is going to impact the value at A also. If I will make changes in, if I will assign a new value to this B 0, 0, the same value will get assigned to A because both are sharing the same memory location. Do you got this point?
Yes, sir.
That's why when I am assigning a new value to B, it is also impacting A. This was one very important point. Now, sometimes this thing will may not work. So we have to be very careful while assigning this, because we have already studied about copies and views. If you will make a copy, this is here you are doing an assignment. Here you are assigning values. But if you will make a copies, then it will not impact. Sometimes what happens that reshape also returns a copies. So I'm writing a note here, note, and be aware reshape may also return a copy. Let's do it right. One by one I am writing. First write A is equal to np dot zeros and zeros, write 3, 2. 3, 2. And let's print A. This is my A. 3 column, 2 rows. Sorry, 3 rows and 2 columns. Now after that, I'm assigning this value, transpose value of A. If I will write A transpose, first write A transpose. See what I am getting? I am getting the transpose of this. This column will get is converting into rows, this rows. Now after that, what I'm doing? I'm doing reshape, 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 and let me write this reshape as 3 into 2. This, sorry, 3 into 2. This reshape will only be occur if it fits whatever value inside this. If 3 into 2 is 6, so reshape will be done. Otherwise, if let's say something else will, if this will get mismatched, then reshape will not happen. So if I will do this, I will get this thing. That is, I want to reshape this into this thing. 0 1 0 0 0 0 0 0 0 0. This is now I am assigning this inside this variable b, this reshape thing. Let's assign this inside this variable b. Let's run this. Fine. If you are doing this now, if you are doing b, let's see what is inside b. Same thing you will get. Now, if you will do b 0, and let's assign 50 here. So what will happen? If you will see b, you will get this. Let's say a. Can you see this time there is no changes in a? The value of a has not changed. What was my a? This is my a, and I have assigned this inside b. I have made changes inside b, but instead of this, there is no changes inside a. So I have shown you this because sometimes it happens. Reshape may also return a copy. Here what is happening? This reshape operation is returning me a copy. So even if I am assigning it, it has no impact. Do you got to this point?
Yes, sir.
So earlier it was, earlier it is changing, but this time it is not getting changed. So this is one very important concept. So it may happen sometimes that when you will do the reshape, this will make a copy, and if it will make a copy, then there will not be any changes inside the A if you will make any changes in B. Now, there is one more very important thing. Let me discuss it. Adding a dimension. We have discussed this. Adding a dimension. We have already discussed this. How we used to add dimension, np.new_access, we has to. But there's one important catch here that I would like to tell you. If you will use, let me explain this here. If you will use np dot new access to add an access to an array, new access to an array, what it means, it will increase the dimension of the existing array by one more dimension. It will increase the dimension of the existing array array by 1. What it means? If there is a 1D array, let's say, it will become 2D array. If there is a 2D array, it will become 3D array. And if there is a 3D array, it becomes 4D array. And so on. And so on. So this is means it will add a dimension to that array. So now we will going to see this with the help of example. So code. Let's write one array. Let's write an array here. Z is equal to, or let it write here, Z is equal to np dot array, and let's write one dimensional array 1, 2, 3, and let's see Z. Fine. Now, if I will add a new access to this array, let's write new access to this array. np dot, this is a 1D array. You know this is a 1D array. New access. And if I will run this, I am getting this. Now the dimension has changed. If you will check the dimension of this dimension, earlier it was a 1D, now it has become 2D array. Now, there is concept called dimension shuffling. Let's understand the concept of dimension shuffling. Dimension shuffling. SHUFFLING. Dimension shuffling. What this concept says? See, if A is equal to, let's say if A is equal to np dot arrange, and let me write 4 into 3 into 2. This is dot reshape 4, 3, 2. What it means? Simply, I'm creating one array, and in that array, and this is a 1D array. This array is my 1D array. Simply, this I have written 4 into 3 into 2 just for your understanding. You can simply write it 24 also. You can write it. There is no issue in that. And this will create np dot, let's say right here, arrange. If you will write 24, what it will create? It will create a 1D array. 1D array. Fine. Having 24 elements inside this. Having 24 elements inside it. Do you got this now?
Yes,
now
sir.
what
Yes, sir.
So let's break this into parts and do it so that it will be comfortable to understand. Let's first create this array. Let's first create this array A. Fine. So I am getting this array 0 to 24. Now I want to reshape this array. So what I will do? Simply write A is equal to A dot reshape, and you have to give, let's say I want 4, 3, 2. I want to reshape this array by 4, 3, 2. These 3 dimensions I want to reshape. This is my 1D, and I am reshaping it into a 3D array. So, and after that, if you will see the shape of A dot shape, let's say A dot shape, SHAPE shape. See what will happen? Are you getting this shape 4, 3, 2? if you will see A, you will get this thing. What it means? What this 4, 3, 2, can you see this 1D array get reshaped into 3D array with the help of this reshape function? But only thing is that this should match whatever the reshape thing that you are giving here. On multiplying this should match with all the total number of values inside it. If this will match, then the reshape will get performed. Now let's understand this very important thing, how this works. This 4, 3, 2, what it means? This means this is a 3 dimension. This is my row, this is my column, and this is my matrix. This is how the 3 dimension is created. It means now the new array will have 4 matrix. So this is my first matrix, this is my second matrix, this is my third matrix, and this is my fourth matrix. So it means it has 4 matrix with 3 rows and 2 columns. That means first it has 4 matrix, and each matrix will be having 3 rows. This is my first row, this is my R1, you can write R1, this is my second row R2, this is my third row R3, and this is my column, first column, second column. So every matrix will have 3 rows and 2 columns, 3 rows and 2 columns, 3 rows and 2 columns. So have you got this point, this thing? 4, 3,
Yes,
2. So this means 4 matrix, 3 rows and 2 columns. Now let's see one very, this was also a very big, very important concept. Now let me, if you want to access any value, let's say I want to access the value, this value, this value 5. So how you will access this value? Let me tell me, if you want to access 5, this 5, how you will do it?
Sir,
So you have to tell me. Yes.
Sir, 4, 2,
4,
1. 2, 1.
4,
2, 1.
2,
1.
How you are writing? How you will telling me this thing?
Sir, instead of 4, 1 should come. Instead of 4, 1 should come. Yes, sir.
Instead of this 4, 0 will come. This is 0. This is, if you are indexing it, then you will start the indexing from 0.
0. Okay, sir.
0, 1, 2, 3. When you are giving the value, then it will come 4. That means 4 matrix, 3 rows and 3 columns. 3 rows and 2 columns. But when you will be doing the indexing will start from 0. So first 0 will come. Then this is my second row, 0, 1, 2, and this is my first column, 0, 1. So 0, 2, 1 will come. You get it?
Yes, sir. Yes, sir.
Fine. Now, if you will, I am telling you to let's write another array, np dot arrange, and let's write 4. And let me, if you will write this, you will get this thing. Now I want to resizes a dot re size size, and what you have to write 8, fine. If you will write this, you will get, see what you will get. Oh. See what you will get. np.resize function. Do you understand this? Why I am getting this error? See what I have done. A is equal to np.arange 4. Then I want to see A and I want to resize A. So if I want to resize A dot resize 8 comma, and if I want to resize this, okay. Since here, why I am not getting cannot resize an array that references or is referenced by another array in this way. Use the np.resize, or so it is not getting resized because A has some other references. And what is that reference? A is referring to B. Can you see? This is referring to B. Since it is making the reference to some other array, that's why I am not able to resize it. Instead of this, if you will simply use some other thing that we have not yet used, let's write here D is equal to np dot resize, sorry, np dot arrange, let's write arrange 4, and if you do D dot resize, and if you will write 8 comma, and if you want to print it, it should work. Can you see? So what is happening, I will explain you both. First, you see here I was not able to do the resize because this A has some other references. So that's what I am getting in the value error. Cannot resize an array that references to or is referenced by another array in this way. So since it is making a reference to another array, that's why I am not able to resize it. That's why I have created one another array D.
Sir?
Yes, tell me.
Sir, which another array is it referring to?
See, this A, which A I have created, this A has a reference. Earlier when I have created, actually earlier also I have created A with the same value, I suppose. And that's why it was making a reference to that. Earlier, since this is 1, 2, 3, 4, can you see 1, 2, 3, 1, 2, 3, 1, 2, 3? See, earlier, see, anywhere inside this program, if I will simply clear this output and I will run this, I will get this also.
No, sir, I understood.
If I will create the output and if I will run this, because it is very difficult to keep the track in the Jupyter notebook. Fine.
No,
if
sir,
I will simply
fine.
clear this output and run this will also get run. But it is not getting run. I will explain you this in a more elegant way. Let's suppose this must be making a reference to some other other variable also. That's why it is not getting. I will explain you in just a second. First, let's understand this. See, I have made one array and I have resized this. See, when I have created this array, this is very important. When I have created this array, this array was, I was like a range 4. So what I shall get? 0, 1. So 0, 1, 2, 3. This is the array. But what I am asking it to resize into something different. 8. This has only 4 elements, and I am asking it to resize it into 8 elements. So what it will do, it will simply add zeros after this. So it is adding 4 zeros here. Do you got this? Varun?
Yes, sir.
So it is simply adding 4 zeros to resize it into 8. Now, let's me clear this concept of above because you are feeling a little confused. So let me clear this thing. See, this is my array D. Now, if I will make, if I will write here, let's say P, fine, P is equal to D. Let's write P is equal to D. What I want to say, I am making reference of P to this D that I have created here. And now I want to resize P. P dot resize. Let's do P dot resize. And resize to 4, comma, this thing. Am I getting value error?
No.
Hello?
No, sir. No.
What? No, I am not getting.
So you are not getting the value because it is referring to the previous one.
Yes. And same error I was getting here also. Cannot resize an array that references or is referenced by another array in this way. Same error.
Yes, sir. Yes, sir. Sir, understood.
So now is this thing clear to you?
Yes,
Fine.
sir.
Fine. Now one last concept that I am going to discuss. This is the last concept for today, and I'm actually getting late because I have to go to the Chhat Puja. My mother is doing the Chhat Puja. So let's just finish it. So let me explain you sorting, S-O-R-T-I-N-G, sorting data. So for sorting data along the axis, let's write along the axis. A is equal to, let's write A is equal to np dot array, and let's write 5, 4, 6, and let's write another, let's write 2, 3, 2. Fine. Here also write 2. Fine. So this is my array. How it will, let's first explain you. Let's see. This is my array. 5, 4, 6. It is 2, 3, 2. If you will sort this array row wise, so what will happen? If you will simply sort this array row wise, what will happen? First, this 4 will come, then this 5 will come, then this 6 will come. If you will sort this row wise, this row. First 2 will come, then 2 will come, then 3 will. This is how we used to do sorting. Same thing I am writing here. So for sorting along the row, what I have to do? I have to write, let's write B is equal to np dot sort. I have to provide the name of the array which I want to sort, and I have to also give the axis on which, since I want to sort it along the row, so I am giving the axis is equal to 1. If I will, and then if I want to see B and run this, can you see? I am getting 4, 5, 6, this 4, 5, 6 and 2, 2, 3 because it has sorted along the row. If you want to sort it along the column, for that you have to provide the axis 0 also. You can also able to do it like this. You do not need to save it in a new variable B. You can directly also do it like a dot. Simply you have to do a dot sort, and simply if you will do axis is equal to 1, this will also do the same thing. And if you want to see A, you will get the same thing. There's no changes in this. Have you understood this? This is also called in place.
Yes, sir.
In place sorting. In place sorting. Fine. Now, one last thing that I would like to discuss with you. This is called sorting or fancy indexing. We have already studied about the fancy indexing in the last session, I suppose. Sorting thing with fancy indexing. Sorting with fancy indexing. So let's write A is equal to np.array, and let's write 4, 3, 1, 2. 4, 3, 1, 2. So this is my, let's say, array, and I am taking one variable j, and I am writing np.arg sort. I want to sort A. What this arg sort means? So let's do it one by one. Let's do it one by one so that it will be understandable. Is will be okay. np dot okay. Indentation it. So this is my A. Fine. Now, if I will write j is equal to np dot arg sort, and if I will write A here, and then if I want to print this j, see what happens. I am getting 23120. So let's first understand what is this. This fancy indexing, let me explain you this. See, I have this array 4, 3.
Sir, I understood it.
1, 2.
It is sorting according to the index of the
Correct.
values. According to the index of the value.
Index of the value. Correct. So can you explain me?
Yes, sir. Sir, like the smallest value is 1.
Smallest value is 1, correct?
And index of 1 is 2.
So let me write the index 0, 1, 2, 3. So index of 1 is 2.
2.
Fine. So 2 is coming here.
Yes.
Then
Sir, then
second value
sir,
is
2. So sir, 3 will come.
so
Index of 2 is 3.
of 2 is 3, so 3 is coming
Yes.
here.
Sir, then the value is 3 and index of 3 is 1.
1. So this 1 is coming here.
And sir,
And
last one is 4 and index is 0.
Correct. You have got the point. This is how we used to do the arg sort. And if I will simply write, let's see if I will simply write here A J. So what I shall get? I will get 1, 2, 3, 4. What it means? If I am asking it and I am giving this index value, it is supplying me, it will give me the value at that particular index. 1 is my value at the second index, this index. So I am supplying J here. J is my this thing. I am supplying J here. So it is giving me the value accordingly. You got this point?
Yes, sir.
So see, I suppose you have understood this broadcasting thing very well.
Yes, sir.
Have you understood this flattening operation well?
Yes, sir.
So this is the end of the today's session, and I am a little. Let me just commit this code to GitHub. Completed the 4th session on NumPy. Just commit this code. Yes. Sync changes. Okay. So fine. So my code has been committed. Now I'm stopping the sharing of my screen. So Varun, share me your feedback of today's session. How how have you liked this session? What are the good thing about this session? What are the bad thing about this session? Everything that you want to share, please share. Then I will end this meeting.
सर सर
आप हिंदी में शेयर कीजिए, कोई बात नहीं, और वीडियो अपना ऑन कर लीजिए फॉर द टाइम बिंग। जी बताइए।
सर आ गया था सारा समझ में।
सारा समझ आ गया था?
हाँ सर।
चलिए, आप बहुत इंटेलिजेंट भी है, क्योंकि जैसे मैंने लास्ट थिंग ऐसे ही आर्ग सॉर्ट, इसका मतलब आपने रिवाइज किया अच्छे से, तभी आपने तुरंत पकड़ लिया कि आर्ग सॉर्ट क्या होता है। सो दिस इज वेरी गुड। मतलब मुझे तो बहुत मजा आ रहा है आपके साथ आपको पढ़ाने में, और क्योंकि ऐसे लोगों के साथ मजा आता है जो खुद मेहनती होते हैं।